Welcome to the Deep Dive, the place where we take complex industry challenges, strip away the jargon, and get straight to the essential, frustrating, and ultimately fascinating truths hiding just beneath the surface. Now, we often view professional software developers as these, artisans of logic, people who speak machine language. They're problem solvers, and their main tool is the keyboard.
That is the common perception, yeah, for sure. But if we really analyze the stack of sources we have today, and we're talking about notes from decades of software experience, a lot of research on project failures, deep dives into Agile, we're kind of forced toward a surprising conclusion.
Which is?
The role of a professional developer is fundamentally, and I'd argue primarily, a communications role. It's not just a coding role.
That's a huge reframing. Because if you think about it, the actual act of writing the code is just the final sort of mechanical translation. Before any of that happens, there has to be a thought.
Yeah.
And that thought has to be communicated.
Yeah.
And if we go back to that fundamental principle of computing garbage in, garbage out, it's pretty obvious where the real friction must come from.
It is. The most elegant, beautiful code in the world cannot fix a rotten requirement. And that principle, it just applies relentlessly to communication.
Between everyone.
Everyone. Between programmers, between team members, and I think most crucially, between the development team and the business stakeholders. The people who actually pay the bills.
Right.
If the requirements coming in are ambiguous or incomplete or just plain wrong, the product that comes out, no matter how much technical genius you pour into it, it's going to fail. It's just not going to meet the actual need.
So, okay, what's the mission for our deep dive today? Where are we focusing?
We are focusing really intensely on what these sources identify as the single greatest communication issue in the entire history of software development.
That's a big claim.
It is, but it's true. It's communicating requirements. We're going to meticulously pull apart how these misunderstandings happen. We're going to look at the behavioral traps of, specifying things too early or too vaguely. Okay. And then we're going to zoom in on the one formal, unambiguous technique that's been proven to resolve this constant crisis, acceptance testing.
And we have to start with this core tension that just makes the whole problem so difficult. The business stakeholders, they genuinely believe they know what they need, and they say it as best they can.
Right, and the developers, they take those instructions and they build what they believe the business just described.
But then reality hits.
Reality kicks in. The system actually runs, and it's almost always filled with errors or omissions or just complete surprises for the stakeholders.
They realize way too late that something got lost in translation.
Precisely. And before we really get into the mechanics of how that failure happens, let's formally define our solution. When we talk about acceptance testing here, we need to be really, really specific.
Okay, so this is not just, the final stamp of approval from the QA team at the end.
No, not at all. Acceptance tests are documents, and these documents become executable code. They're written collaboratively by the stakeholders, often through, business analysts or testers, and the programmers.
And their purpose.
Their singular vital purpose is to formally, mathematically, and unambiguously define the exact criteria under which a requirement is considered done. They are the executable contract of completion.
So if the test passes, the job is done, period.
If the test passes, the requirement is complete. It doesn't matter what anyone's subjective feelings are. It doesn't matter what assumptions were made. It's proven.
That really moves the goalposts from just, feeling good about the code to having actual proof the business need was met. Okay, let's jump in. Let's get to the origins of this problem, the human element. Why is it that requirements always seem to change, even when we think we've nailed them down? So let's unpack this core communication problem with an anecdote, because you have one that just perfectly captures this chasm between the developer's world and the stakeholder's reality. It takes us way back, 1979, and a very long day you spent at a company called Teradyne.
The story of Tom, yes. I was working with a system based on the M365 computer, which was basically a clone of the old, venerable PDP-8.
A classic.
A classic. And we used this proprietary text editor called ED402. It had this incredibly powerful built-in scripting language, but it was, let's just say it was deeply esoteric.
Okay, so in walks Tom, and he's the manager of installation and field service, and he comes to you with what sounds like a classic business problem. He needs a simple trouble ticket system.
That's right, an internal one for his field service reports. And in my typical, developer mindset, I saw this as a trivial application.
Famous last words.
Absolutely. I thought the scripting language is powerful enough. I'll just teach Tom how to use the editor's macro language and he can build the simple system himself. I actually thought I was empowering him.
A noble goal,
Hmm.
but one that I'm guessing immediately slammed into a wall.
A brick wall of domain expertise. It was a spectacular failure. I started showing him how to, create a text file to hold the script, how to name it, how to use these special symbolic representations for the editing commands.
Okay.
I was trying to explain that if he wanted the script to begin editing at the current cursor position, all he had to do was type the Control-B command, which was the editor's shorthand for that.
And Tom's reaction, just a blank stare.
Just silence. I could see the gears grinding in his head, but absolutely nothing was connecting. I saw this look of just utter confusion wash over his face. He wasn't connecting my explanation of these cryptic keyboard shortcuts to the business outcome he wanted.
Which was just a working trouble ticket system.
Exactly. My explanation, which was, elementary to me, made absolutely no sense in his world.
That moment is so telling. Because to you, the developer, Control-B is a fundamental building block. It's like a brick.
Yeah.
But to Tom, it was just noise. It was a waste of his mental energy that he needed to be using to manage his field service team. He didn't want to learn how the tool worked.
He just wanted the product.
He just wanted the product.
Exactly. And the process, it shifted instantly and dramatically. Tom realized the mental cost of learning my domain was just way too high. So I stopped trying to teach him. I started implementing the application bit by bit based on his description while he just sat there watching me.
So you became the human interface. The second you showed him even a tiny piece of working functionality, like a single line of text appearing on the screen.
His requirements began to shift and evolve.
Constantly.
Constantly. Within 20 minutes, the goal was no longer build what we agreed on an hour ago. The goal became make the code reflect what Tom is thinking right now. He'd look at the screen and say, no, not like that. If you press enter there, it should go to this other screen. Then 5 minutes later, wait, that new screen, it also needs to track the part number.
Yeah.
It was hour after hour of this iterative dance.
And you realized.
I realized I was not the architect here. I was merely the tool that he was wielding. He was the sculptor and I was the chisel.
He was discovering the requirement by seeing the result. So what was the big lesson? The essential takeaway from that, I imagine, very exhausting day.
The profound lesson, which Tom kind of implicitly understood and I learned very explicitly, is that a pure vision of features. It rarely survives actual contact with the computer. What the business thinks they want, what they wrote down on paper, it changes the second they see a working version of it. The gap between the theory and the execution, that's where the requirement truly lives.
And that leads us right into these behavioral traps that just infect requirements processes everywhere. Let's talk about the temptation toward premature precision.
Oh, this is a deep-seated pathology. It's driven by organizational fear and anxiety. On the business side, they want to know exactly what they're getting before they cut the check.
Right, they want a guarantee.
They see precision as a security blanket. And on the developer side, they want to know exactly what to build before they give an estimate or start coding because they crave clarity. They want something measurable.
It sounds rational, though. I mean, if I'm buying a house, I want the blueprints finalized before the construction crew shows up. Why is that so disastrous in software?
Because software isn't a house, it's an evolving system. The sources are really clear on this. Seeking premature precision leads to an enormous waste of resources, time, money, everything. You're trying to achieve a level of detail that will be immediately invalidated the moment development actually starts.
So you spend months writing a massive document.
You spend 3 months writing a 300-page document full of meticulous detail, and the moment the very first feature runs, 50% of that detail is suddenly obsolete.
This sounds a lot like the uncertainty principle from physics, but applied to software. A kind of observer effect.
That's a great way to put it. In physics, measuring a particle changes its state. In software, observing a working feature changes the perception of the requirement.
So what the business wants and what the business sees when the system is actually running, they're just fundamentally different things.
They are. The act of demonstrating the feature provides new information, and that new information fundamentally impacts how the business sees the entire system and its relationship to what they actually need.
So paradoxically, the more detailed your initial requirement is, the more likely the business is to realize that all that detail was wrong once they see it running.
Exactly. They get a better idea of what they really want, which means invalidating all the work you did to define the old idea.
We're dealing with a moving target.
We're dealing with moving targets in a space of almost infinite flexibility. So if you try to nail down every requirement to the nth degree before you start, your estimates, which depend on that precision, become essentially useless. Because the requirements will change. The only certainty is uncertainty.
Okay, so if pinning down all that precision too early is a huge waste, can we just defer it indefinitely? Which I assume leads us to the countertrap, late ambiguity.
Yes. The opposite extreme, and it's just as destructive. Deferring precision is often a sound, agile principle, specifying things just in time. But deferring it for too long leads to late ambiguity, and that allows hidden conflicts to just fester under the surface.
And you suggest this is often a deliberate thing. It's not just accidental fuzziness.
Oh, absolutely. When stakeholders disagree about a complex requirement, they might either unconsciously or very consciously avoid resolving that conflict.
Okay.
They find a way to word the requirements so vaguely that both dissenting parties can nod their heads and say, yep, I agree with that. They create a false consensus. They just kick the can down the road.
And the person who eventually gets tripped by that is usually the programmer, much later in the development cycle.
Precisely. One of the most cynical, but I think most accurate observations cited in the source material is this. An ambiguity in a requirements document represents an argument amongst the stakeholders.
Wow.
The developer gets handed this vague statement and is now tasked with resolving the internal political conflict of the business, usually incorrectly, when they finally have to make a concrete choice during implementation.
So both extremes are bad. Premature precision wastes time on details that will be instantly outdated. And late ambiguity just hides conflict that blows up the product later.
The goal, then, has to be the right level of precision at the right time.
So if the human element is always going to introduce this shifting vision and this, conflict avoidance, how do we as professionals create a standard? Something that ensures a requirement means the exact same thing to the business analyst, the developer, and the end customer.
We have to formally, and I mean formally, address contextual ambiguity. We have to stop relying on the shared context of a spoken conversation. The second that conversation gets written down or passed on to a third person, the context is lost and the meaning just shatters.
The classic example you use for this is the log file backup scenario. It sounds so simple.
It sounds trivial.
But let's trace the catastrophic breakdown that happens just because of ambiguity.
Okay. So we start with a conversation between Sam, who's the stakeholder, and Paula, the developer. Sam says, I need the logs backed up. Paula, being professional, immediately starts to drill down.
She knows backup is a totally meaningless word without more context.
Exactly. So Paula asks, how often do you need this log file backed up? Sam says, daily. Paula says, okay, and where do you want it saved? This forces Sam to clarify that backup doesn't mean archiving to the cloud or tape. It literally just means saving the file to a specific subdirectory on the server every day.
Right. They negotiate the timing, they settle on midnight, they walk away believing they have a complete, solid agreement.
Yes. But then Paula hands the task off to Peter, another developer. And this is example 2, the developer handoff dialogue. Paula briefs Peter on the high-level task, copy the log file into a subdirectory named backup every night at midnight. Peter, who has to actually code this, rightly asks a critical question that Paula and Sam never even considered.
What's the question?
He asks, okay, what file name should we use for the backup copy?
Oh, the devil's always in the file name.
Absolutely. And Paula, who's probably just tired of the details at this point, she dismisses the question way too quickly. She says, oh, log.backup ought to do it. Just keep it simple. Peter says, okay. Now, think about that.
If the task runs every night and they copy the active log file to log.backup,
What happens to the file from the night before?
it gets overwritten.
It's overwritten. Every night, they save the current log, and they destroy the previous one.
So they established a precise process for preserving a file for 24 hours, but they never addressed long-term archival at all.
Not at all. And that leads directly to the ultimate failure point. Example 3, the customer misunderstanding dialogue. Sam goes to talk to the customer, Carl.
Okay.
And Carl explicitly states the critical business need. He says, it is vital that we never lose any logs. We need to be able to go back through all those log files, even months or years later whenever there's an outage, to trace the issue.
And Sam, feeling confident because he talked to Paula, says,
He says, don't worry, we are saving the logs into a directory named backup every night at midnight. And Carl is satisfied. He believes he's getting an indefinite cumulative archive.
And the catastrophe is realized months later when there's an outage and the customer finds only one file. the log from last night, named log.backup.
Exactly.
The professional developer's job was to remove all that ambiguity, and they failed to ask the one question that defined success. Are we retaining a single file, or are we retaining a sequence of files?
Exactly. The source material is adamant about this. The responsibility lies equally with professional developers and the stakeholders to relentlessly pursue clarity until all ambiguity is gone. And that process, it has to be formalized.
And this need for formal, unambiguous clarity is best served by defining the most common professional ambiguity of all, the meaning of the word done.
Oh, yeah. When a developer says, "I'm done with this task," that statement is almost always ambiguous.
What does it mean?
Does it mean they've finished typing? Does it mean they just feel personally confident in the code quality? Is it ready for quality assurance?
All those weak definitions, they're just based on feelings or handoffs. They're totally unsustainable.
Absolutely. The professional definition of done is singular, and it's uncompromising in the professional world. Done means all code written, all unit tests pass, all acceptance tests pass, and QA and the stakeholders have formally accepted the resulting behavior. That acceptance part is non-negotiable.
So if we're going to rely on acceptance tests to define done, then those tests can't just be documents. They have to be executable.
Precisely. Automated acceptance tests are what drive the detailed specification of the requirement. You work with the stakeholder and QA to ensure that the set of automated tests represents a complete specification of what is required, right down to the file names and the archival schedules.
So when those automated tests pass,
When those tests pass for a feature, they provide verifiable, executable proof that the requirements have been met. They are the bridge that keeps your progress consistent and verifiable, iteration after iteration.
okay, let's get deep into the mechanics of acceptance testing then. Let's see how they force this level of clarity that we're talking about. We go back to that log file scenario. But this time, the team is using an acceptance testing framework to force precision. And we introduce a new character, Tom the tester, whose job is basically to interrupt and challenge every vague assumption.
Right. This is the refined log file dialogue, and the focus shifts completely from what do we want to how do we prove we actually got it. Sam and Paula are talking about the backup, and Tom immediately steps in as the gatekeeper of precision.
What does he say?
Tom says, "Wait, backup is too common a name. We need precision. What are you actually storing in this directory?" Sam says, "The log file backups." And Tom pushes back. "Backups of what? Do you mean the active log file, or do you mean an archive of all past logs?"
That distinction, active versus archive, that is the exact pivot point they missed the first time.
It is. This forces Paula to reveal her original assumption. She says, "Oh, I thought you just wanted a temporary file saved once a day." And Sam can then correct the record decisively. "No, the customer needs to keep them all, forever, for diagnostic purposes."
That is the moment where ambiguity is formally destroyed by the process.
It is, and this clarification leads to a much more precise naming convention. The directory must be called old inactive logs, but the process doesn't stop there. Tom, the tester, then insists on writing the executable test structure right then and there to lock that clarity in. They realize they can't test this detail by running the entire complex system startup, which could take, 5 minutes. They need to isolate the functionality. So they decide the creation of this specific folder should be handled by a dedicated log file directory start command object. This isolation allows them to write fast, executable tests using a formal structure called a fixture specification.
And this is where we leave behind prose and we enter the world of executable documentation. So for you listening, what is a fixture and why is this structured approach so essential?
A fixture is basically the environment that's required to run a specific test, and the structure, which often uses the Gherkin syntax. Given when, then, is essential because it translates human language into a form that a machine can execute.
So given sets the scene.
Given sets the initial condition, when defines the specific action you're taking, and then states the verifiable result. It removes all ambiguity about the sequence of events.
So let's look at scenario 1, testing the creation of this directory.
Right, so the test has to confirm that the system handles a cold start. It looks exactly like this. Given the command, log file directory start command is prepared, given that the old inactive logs directory does not exist on the file system when the command is executed, then the old inactive logs directory should exist on the file system and it should be empty.
That's mathematically verifiable proof of the correct startup behavior.
It is, and scenario 2 tests persistence. Because if the folder already exists, the system absolutely should not wipe out the precious archived
Right,
logs.
you have to test for that.
You have to. We test for idempotence. Given the command, log file directory start command is prepared, given that the old and active logs directory already exists, and that it contains a file named log0001.txt. When the command is executed, then the old and active logs directory should still exist, and it should still contain the file named log001.txt with no other side effects.
So by writing this, the developer knows exactly what behavior is expected.
And the business knows exactly what behavior is guaranteed.
Now, when Sam, the stakeholder, sees this level of just meticulous detail, the natural human reaction is often skepticism. Wow, is all of that really necessary? Isn't this just more work?
And that is the crucial moment where the team has to defend the process. And the immediate answer is, no, it is less work. Writing this formal, unambiguous test one time is significantly less work than executing a manual test plan every week for 5 years.
Or fixing a massive bug months after release because of that initial communication failure.
Exactly. The precision is the efficiency.
Okay, so this level of rigor, it immediately brings up the classic question about redundancy. If we have these incredibly detailed acceptance tests defining the system's behavior, do we still need those unit tests that programmers are always writing?
Yes, absolutely. It is vital to understand that they are not redundant. They serve entirely different masters and entirely different audiences.
Okay, let's clearly define that distinction then by audience and purpose. Unit tests.
Unit tests are written by programmers, and their sole audience is other programmers. They are formal design documents that describe the lowest level of structure and behavior, a specific class, a specific method.
So their main job isn't even really testing the business logic.
Right. Their primary function is to serve as living documentation of the code's internal architecture. They allow developers to refactor safely. They're like the internal map of the engine.
Okay, and acceptance tests.
Acceptance tests are written for the business and its delegates. The audience is both business stakeholders and programmers. They are formal requirements, documents that specify system behavior from the high-level business point of view, the external interface, the API, the user interaction. Their primary function is to automatically verify the system against the stated business need.
They're the external quality assurance contract.
Exactly.
So while both sets of tests might confirm that, say, an interest calculation is correct, the unit test confirms the integrity of the interest calculation class method itself. And the acceptance test confirms that when a user clicks the Calculate button via the API, the correct final result is actually displayed to the customer.
That's the perfect analogy. They're looking at the same function from opposite ends of the telescope. They complement each other. You have internal safety from the unit tests and external validation from the acceptance tests. You absolutely need both to be professional.
Okay, we've established that acceptance tests have to be formal and unambiguous. Now let's turn to the economics of it all. The source material makes an absolute mandate here. Acceptance tests should always be automated.
Always. And the reason is purely economic. Manual testing is dramatically and continuously more expensive than writing automated scripts. This is often the hardest point to convey to management.
Why is that?
Because they see the initial cost of writing the automated script, but they fail to calculate the compounding, recurring cost of manual execution.
Let's use that really powerful image from the source material to drive this point home, the million-dollar disaster. Tell us about the QA manager who was facing that huge budget cut.
Right, so imagine a massive enterprise, a global internet company. They're dealing with a huge, complex legacy system. And the QA manager oversees this enormous manual test plan, thousands and thousands of steps, that is executed by an army of testers, often offshore.
Okay.
The plan takes 6 weeks to complete, and they have to run it about 6 times a year every time they do a major release.
And what was the actual cost of that manual effort?
Every single execution of that test plan cost the company over $1 million.
$1 million.
$1 million in labor and overhead. A recurring cost just to manually click buttons and verify output on spreadsheets, ensuring the system still worked. This is the real cost of non-automation.
And then the inevitable corporate mandate comes down.
Yeah.
50% budget cut.
The manager is faced with this horrifying, impossible choice. He's holding a manual test plan that is mission critical to the business, and he is now forced to ask himself, which half of these tests should I just skip?
He has to choose which 50% of his product he is just going to stop validating.
He has to sacrifice quality assurance and simply live with the fact that he has no idea if half of his system is still functioning correctly before it goes out to the customer.
That is the financial and professional catastrophe of relying on manual acceptance testing.
It is. The initial investment in automated tests, it seems high, but compared to the recurring, compounding million-dollar cost of manual execution, automation is the only financially responsible choice. It is not extra work. It is the cost of staying solvent and professional.
And if the concern is that automation requires every business analyst or tester to be some kind of coding expert, the tools have pretty much solved that barrier now.
Oh, absolutely. Tools like Fitness, Cucumber, Selenium, they've been specifically designed to enable non-programmers to read, write, and execute these automated tests. They use simplified, structured, natural language, like that gherkin given when-then syntax that compiles into executable scripts. It really bridges that communication gap.
So given that automation is a must, who takes primary ownership of writing the content for these tests, and when do they do it?
Ideally, the stakeholder, the business and QA collaborate, and the developers review them. But, because stakeholders often lack the time or the inclination to get into the weeds, the task typically falls to business analysts and QA specialists.
And how do those two roles usually split the responsibility?
The business analysts, they typically focus on the happy path. That's the core profitable business value scenarios. They define what the system is supposed to do when everything goes right.
And QA?
QA then takes ownership of the unhappy path. The boundary conditions, the exceptions, the error handling, security risks, all the corner cases. QA is professionally trained to think about how a system might fail, which makes them absolutely indispensable here.
Okay, and the timing. We establish we want late precision, but it has to be before the implementation starts.
Right. So following that principle of late precision, the acceptance test should be written just before the feature is implemented. In an agile world, that means they're written after the feature has been selected for the upcoming iteration.
So they have to be ready by day one of the sprint.
They have to be ready by the first day or at least the midpoint of that iteration. If the developers hit that midpoint and the acceptance tests aren't ready, the developers have to stop building new features and help author the tests, because the implementation cannot be completed without the definitive contract of correctness.
Once the tests are written, the developer starts coding. But their job also requires challenging those requirements. This is where we get into test negotiation and avoiding passive aggression.
Right. A professional developer never, ever exempts a flawed or ambiguous test. The test author, whether it's a BA or QA, is human. They make mistakes, they make assumptions, they use vague language. The developer's job is not just to implement the test, it is to challenge the test author for a better test.
And what's the danger of passive aggression in this situation?
Passive aggression is when the developer sees a flaw, they know the test is wrong or ambiguous, but they implement it anyway, thinking, well, they wrote it, so if it fails, it's their fault, not mine. That is a complete failure of professionalism. You are paid to build correct software, and correct software requires correct verifiable requirements.
So let's use the ultimate example of rigor here, the Z-score negotiation. This forces the team to move from fuzzy business language to an explicit mathematical contract.
This is a great demonstration of developer rigor. So Paula, the test author, she writes a performance requirement. Ensure that the post-operation finishes in 2 seconds. Tom, the developer, knows this is impossible to guarantee. Absolutely.
Right, because networks fluctuate, hardware load changes.
Latency is inherent. So Tom says, Paula, I see the 2-second requirement, but we can only make that guarantee in a statistical sense. We can't guarantee an absolute completion time.
And Paula, who's just focused on the business needs, she tries to compromise using, human language.
She suggests, okay, Tom, let's just settle on 99.5% of the time. That sounds safe. But Tom insists. He says 99.5% is not the stated requirement. The stated requirement is an absolute guarantee, which I cannot provide. You need to define the test statistically.
Why is 99.5% not good enough? It sounds pretty specific.
Because it's not specific enough to test reliably. It's a fuzzy comfort number. To actually test it, Tom would have to run hundreds of thousands of transactions. They need to define the requirement in a way that is mathematically testable within a reasonable window of time.
So they negotiate, and they realize the solution requires some actual statistical tools.
They move from a simple percentage to the Z-score.
And what was the final precise requirement they landed on?
They agreed. Execute 15 post-transactions and accumulate the times. Ensure that the Z-score for 2 seconds is at least 2.57.
Now that looks like pure mathematics, but it's actually pure communication. For you, the listener, who might not be an expert in advanced stats, can you just quickly explain what that z-score represents in simple terms?
Sure. A z-score measures how many standard deviations an observation is from the mean average. When they settled on 99.5% of the time, they were looking for a high confidence interval. The z-score of 2.57 corresponds precisely to that 99.5% confidence interval.
So by demanding this, Tom forced the stakeholder to define the requirement not as a feeling, but as a model.
An explicit, verifiable statistical model. Now, instead of guessing, they can run 15 transactions, calculate the average and the deviation, and verify if the 2-second threshold meets that 2.57 z-score. It's no longer negotiable, it's a proven fact.
That really shows the power of these formal testing structures to elevate the quality of the requirements themselves.
Okay, now let's address the most volatile interface of all. The graphical user interface, the GUI. How do you write stable, automated tests for something that is designed to change constantly for aesthetic reasons?
This is a major track for teams that are new to automation. And the source material is very clear. Testing the GUI itself is highly problematic, and you should keep your GUI tests to an absolute minimum.
Why are GUIs such fragile targets for automation?
Because they change for different reasons than the business logic does. Aesthetics are subjective. Managers constantly want to tweak fonts, adjust layouts, reorganize workflows, move buttons. If your test relies on the button being at coordinate X, Y on the screen, the test breaks the instant a designer moves that button.
So you spend all your time just maintaining brittle tests instead of writing new features.
Exactly. So we apply a foundational principle of professional design here, the single responsibility principle, or SRP.
And SRP says that things that change for different reasons should be separated. Exactly. The GUI changes for aesthetic reasons. The underlying business capability, the function that's invoked when the user interacts, that changes because the business needs change. They have different responsibilities and different rates of change.
So what's the best practice for testing? How do we verify the function without relying on the visual volatility?
You must design the system so that you can invoke the features of the underlying system through a real API, the same exact API the GUI uses, rather than trying to simulate human clicks based on coordinates or labels. You write the tests to interact with the stable business logic layer.
So if I have a submit order button on the screen, my acceptance test doesn't click the visual button.
No. It calls the submitted order method in the API directly.
That's the ideal. You decouple the UI tests from the business logic tests.
Right. And if the GUI changes tomorrow, different colors, different workflows, all your critical business logic tests still pass because they're testing the underlying stable API. You use a bare minimum of GUI tests just to confirm basic connectivity and presentation, but never for critical business logic.
And finally, none of this formality, none of this rigor matters unless the safety net is running constantly. This is the mandate for continuous integration, or CI.
Continuous integration is non-negotiable. You must ensure that all your unit tests and all your acceptance tests run several times per day via a CI system. This is typically triggered every time a developer commits a module to the source code control system. The whole point is immediate feedback.
And when a test fails, when the build breaks, what is the most critical professional rule? The stop the presses rule.
It has to be viewed as an emergency. The moment a test fails, the entire team, developers, testers, everyone must stop all work on new features and focus entirely on fixing the broken tests immediately. If you don't treat it as an emergency, the build stays broken and the safety net just vanishes.
And you've seen organizations that fail to enforce this rule. What happens when the culture just allows broken tests to linger?
It always results in organizational chaos and massive expense. I worked with one team where the CI build was broken maybe 60% of the time. Developers would check in code, they'd see the failure, and they'd promise to fix it later. I'm too busy, I'm chasing a deadline.
And eventually, seeing that constant red warning light just became inconvenient.
It did. They normalized failure.
So they took the ultimate passive-aggressive step.
They took the broken tests out of the build entirely. Their reasoning was they'd put them back in once they had time to fix them. They effectively removed their own safety net and convinced themselves they were now making faster progress because they weren't being interrupted by all those red lights.
That is the ultimate act of professional denial.
It is. They released the product based on this false sense of security, assuming that the tests they'd removed were, at least temporarily, still working. And the inevitable happened.
Angry customers.
Angry customers started calling almost immediately with critical bug reports. The team realized they had forgotten to put the tests back into the build system, and the bugs the tests were supposed to catch had shipped directly to the customer. Neglecting the CI status isn't just poor practice, it's sacrificing the very quality assurance you spent thousands of hours writing in the first place.
This has been a really extensive look into the crisis of requirement specification. We started with this assertion that the professional developer's job is fundamentally about communication, not just about code.
And we found that human communication about technical details is inherently deeply flawed. It's so easy for programmers and stakeholders to agree that they understand each other when, in reality, they often hold completely divergent ideas of what the final product should look like.
Which results in the waste of premature precision and the danger of late ambiguity.
Right. And we saw that the only known way to really bridge this perilous communication gap is through formality. And that formality has to be driven by automation.
So automated acceptance tests are the professional solution.
They are. They're formal, they're unambiguous, and because they execute automatically against the application, they cannot drift out of sync with the system. They translate this vague business desire into verifiable, executable, indisputable fact. They ensure that when you say something is done, you have the mathematical proof to back it up.
And by embracing this rigor, we stop dealing in assumptions and we start dealing in proofs of correctness.
And that frees up the developer to focus on the technical elegance of the code because they know the requirements contract is solid.
So for you, the listener, as you approach your next complex decision or your next project, and this could be in software or any other field that requires precise execution, consider the implications of this uncertainty principle in your own world. What is the feature, the policy, or the requirement that you think you need today that you will inevitably realize you don't want the moment you actually see it running tomorrow?
And if you can anticipate that shifting perspective, what formal, unambiguous acceptance test, what specific sentence, starting with a given, a when and a then could you write right now to save time, prevent ambiguity, and ensure that what is ultimately built is precisely what is needed? Start defining the proof of done before the work even begins.
That's a challenge that really defines professionalism. Thank you for joining us on the Deep Dive.